Greetings! In this video you will see how to realize pretty complex Selenium testing using MPL. I prepared Petclinic-selenium project and two implementations of the pipeline to compare, MPL and non-MPL. Both implementations are using Jenkins files and Jenkins pipeline engine. And they are doing the same, building the Petclinic Maven project and after that running tests on a dynamically created Selenium cluster. This one is non-MPL implementation, and you can see that it's loading Jenkins file non-MPL from the project repository. On the other hand, we have the same results and dashboard, but it's using MPL to simplify the pipeline structure. In the configuration, this pipeline is using different entry file, Jenkins file MPL. Let's check the Jenkins configuration to make sure that MPL is in place. And yeah, the shared library used in the Petclinic-selenium MPL pipeline is here. It is stored in the local Git repository just for example purposes. Now, when everything in place, we can run both pipelines to see that they are actually working. Petclinic-selenium non-MPL pipeline is started. And Petclinic-selenium MPL pipeline is started now. This Jenkins is using Docker containers as on-demand agents to build the project. And now we can see how containers are created and build process is started. Okay, now we leave the process and switch to the project repository to see how it's working. The file you see on the screen is Jenkins non-MPL. So it's describing the pipeline where we don't use the MPL at all. It's prepared in a declarative style, but this is not helping to understand it. Logic is pretty complex, even commentaries don't make it easy. Storing all the logic as one file is not a good idea. But if we will use shard library or scripted pipeline, can we organize it? Unfortunately, it will just create new issues like configuration chaos or mess in logic. Of course, it depends on your organizational talent, but we are here to check the existing solutions. The Petclinic-selenium directory contains the project source code and two Jenkins files. Let's switch to the pipeline using the MPL file Jenkins file MPL. It contains a directive to load the MPL shared library and default MPL pipeline call with a number of configuration lines. Using this pipeline, we can follow the execution logic. First of all, we need to open the MPL sources. Repository is cloned to the MPL directory. As you can see, MPL pipeline step is used here. And we can find it in the interfaces of the MPL located in vars directory. The MPL pipeline.groovy file describes default configuration and pipeline in a declarative style. We have four basic stages which are checkout, build, deploy, and test. Each stage contains one-step MPL model and could be disabled using the configuration. Also, we have a post block here to allow you to do post-pipeline actions using MPL post-step mechanism. In the typical stage like checkout, we have just one step, MPL model. Without parameters, it will run model with the current stage name. We can locate the models of library in the resources directory. And checkout model is right here. It's loading the lower level models, git checkout or default checkout depending on the configuration provided. And we can see those models placed near. Git checkout.groovy cloning the remote repository using the pipeline configuration. And default checkout.groovy using repository from the Jenkins job config. Okay, going back to the pipeline definition, we can see the next stage. It is build. We have build model in the MPL, but it's overridden on the project side. MPL will check .jenkins directory in the project before loading models from the shared libraries. And here we can see that we're still using build model from the MPL, but adding the post step to publish the unit testing report, and after executing the default MPL build model to build Maven project, we are running model to build Docker image if Docker file is existing. The second run of build model can't use the same model from the project, to prevent fall into infinity loop. So it will use the next model in the list, the build model located in the MPL library. And it will run the Maven build model to build the Maven project. OpenShift build model will be skipped, because the project doesn't have an OpenShift directory. But Docker build model will be started, because we have Docker file in the project. And it will create an image with application binaries for the next deployment stage. This stage will run the new application container to make sure that it could be started. The stage logic also prepared locally in the project. We can see deploy.groovy here that running deploy model from the MPL, but actually it's not required. And if the Docker file is existing, it will run the Docker deploy model. The MPL contains deploy model, but it's just an example, so it's doing actually nothing. You see right here, it's loading the OpenShift deploy model, but it just prints some messages. The interesting thing here is Docker deploy model in the project repository. It will ensure that container created by this model will be removed by the described post step. And only when the post step will be registered in the MPL manager, it will run the container by docker run command. The Jenkins is a local Docker container with access to the Docker daemon. That's why we use node master here to run commands on the Jenkins master. The next step after the deploy is the test stage. To perform after deployment testing, we need to set up an environment which will allow us to run Selenium tests. As you can see, the project is completely overriding the test model. Before running the tests, we will care about Selenium cluster, and if no hub URL is provided, it will create a cluster by itself running Selenium deploy model. In the Jenkins file MPL, we can see some configuration lines passed to the pipeline. Here we are providing a Maven profile name and target URL for the Selenium tests run. Next, let's see how the Selenium cluster is deployed. It contains pretty complex logic. First of all, we need to be sure that the environment will be cleaned when the pipeline is done. So here we have MPL post step with required calls to clean it up. Next, we run a network to place all the pieces together. We are adding the current agent to the network to enable connection between Maven and Selenium hub. And after that, it running the hub and the number of minions containing Firefox and Chrome browsers to run the tests. Last step is to connect already deployed container with application to the network containing the Selenium cluster. Seems like that's all we need to run the tests. Selenium Maven test is the last model we need to run during the test stage. It is placed near as Selenium Maven test.groovy. Let's open it. Here we can see the main part is running the tests while providing some parameters and registering MPL post step to collect results after the test execution. I think the pipelines we started is just completed. My notebook actually is not so powerful to run 2 Selenium clusters quickly. And yeah, what we see is success in non-MPL pipeline and MPL pipeline as well. Let's open Blue Ocean interface to see the steps we passed. Here you can see all the steps with their results for each stage. In the list you will find which MPL models were loaded and what steps were executed. For example, after testing Selenium deploy models, we are using the Docker tool and executing all the commands we had talked about. Here we also can see that cleaning of the Docker container post step is not executed correctly, because cleaning of the Docker network we created also removed the container with the application. It's not a big deal, but we can see the errors, and post step execution will report on the issues we're facing. MPL also will report what the model and line has an issue. Okay, seems both pipelines were executed correctly. So what's the difference? Details make the picture, as usual. The difference is in the structure, in usability, in the possibilities provided by the MPL. We can separate logical blocks and provide a simple way of configuration. We can reuse our logic between the pipelines, overwrite or modify it even on project level, if some urgent fixes or specific functionality is required. MPL support distributed structure to allow the teams to work on their automation and at the same time collaborate and share. Plus here is the testing framework for MPL and nested libraries. The MPL gives you a chance to implement your modern future automation. Check the MPL on GitHub. Thank you for your time and see you!